All right, before the break, we started working through a specific example. Decided to go ahead and do the unprepared example. I always like to do those in classes at least once so that y'all don't get too thrown off by how smoothly the normal examples go. Because I'm talking and typing, and I practice those ahead of time. So I always like to do at least one that's unprepared. So we're gonna do a payroll calculator. Went through these steps we were talking about the other day. Getting practice at that other stuff, making a plan, and in particular, predicting the budget and timelines. You get good at that because that's the thing. Those are the two things that will make people the happiest and keep customers coming back over and over and over again. A concept from business, to your early study business, the goal of business isn't necessarily profit. The goal of a business is to continue doing business. So that's not bad when we have the loss years. Right? Some years there's profit, some years there's loss, but the business continues. And profit is really like the nourishment for the business. It's what the business eats in order to survive. But we exist on a different scale than big business and arbitrary concept of business. So it's hard. We think about the profits. But the business needs to keep doing business, and making your customers happy is how you keep doing business, how you keep getting those orders for software. Oh, we had another 15 minutes in here because there's 15 that wasn't even accounted for yet. Right? We didn't. We dealt with a bunch of arrays there right before the break that didn't even make our original time estimate. And that sort of thing takes practice. As you do it more and more, you'll get a better idea of the things you need to predict that are going to be included and get better and better time estimates. So getting back to this, we have all our data over in this file. So we read that in. And when we read it in, we'll go ahead and split it up. It's in the CSV file, so we'll split it up on the commas, and then we have an array representing each employee. We have a bunch of employees, so then we took all those arrays and put them into a dynamic array list to hold all of that. So it's nice and organized. Use the backpack analogy. It's all put in a nice organized container, so we're ready to work with it, carry it around, move it. It's a lot easier to deal with than just a stack of things. So right now we just printed it out. We want to do something better than print it out. We want to do our calculation. We need to find out how many hours each employee worked. So, well, I'll just start with this line. System.out.print. E is all of our employee data for each string E in that array in the array list. So this is each one of our elements. So we need to get to a particular one. So if we do it this way, we need a selection structure. When are we looking at the name? When are we looking at the hours worked? So instead of this, I'm going back to indexes because I can think about that a lot better. I can think about index 0, 1, and 2 because I only have 3 things in each array, right? 0, 1, and 2s, I think will be a lot easier than a big long selection structure. So in I start at 0, I is less than EL, element, employee list, whatever that abbreviation stands for. Actually, I could probably change that to employee. Refactor as we go, so we end up with some nice code that's self-documenting, easier to follow. And employee is the array, not the list. So that means that's from the earliest days of Java, so we can access the linked variable directly. Or on the list, we have to use the size method because our data fields are all private in there. which is what we're gonna start talking about next week. There we go. So now we have some indexes to work with through that array. So actually, don't even need that, do we? We have the whole employee. We have all three of them, so we don't need an inner loop. Still need to work with arrays. I'm gonna go ahead and get rid of that. I don't think we need it. Let me comment it out. Always comment instead of delete. And then you can delete later when you know for certain you don't need it. Because you don't want to be somewhere where your latest idea doesn't work and then you can't get back to the last thing that worked. That happens sometimes. So always comment out instead of deleting. So I'll undo that indenting and print out how many hours did employee, and going right back to the data. It's like name is going to be index 0. Zoom thumbnails are in the way. Over them over there. Employee 0, so that's like Bob. So how many hours did Bob work this week? And then that's probably what we print out there. So we got our prompt, and we saw how to get user input, right? Same way we read from the file earlier. We scan the keyboard, scan the keyboard presses to get user input. We had a scanner earlier, but it was looking at a file. We could reassign it, but I'm going to make a new one. Usually they're two different scanners really. It's the same type of data, so we could reuse that spot in memory, but I'm just going to go ahead and make a new one because normally that's what we want to do. So we need some more scanner data, and this time it's the keyboard. It's going to be a new scanner with our system.in, the system's default input, the one we saw before. And then we can do a string. Might as well we jump right to a double hours. And we saw this before, right? We can do, it should be the next thing on there. So we can do keyboard.next double, just to make sure we're getting a double. And then wrap that in double.parse double. And does this work here? Nope, that didn't work. NetBeans has been around since before that particular shortcut showed up. So if you're used to the ones where you can highlight it and then just hit the opening parenthesis, NetBeans has been around since before that showed up. So what are we on now? Like NetBeans 14, and each one's usually around for 2 or 3 years. NetBeans has been around since pretty much the beginning of Java. Oh, wait. I use the next double method. That does return a double. I was thinking of the next. Let me use the predictive text. So you're going to do something like this. We look at next double. So here on the list, next double, the return type over on the right, it returns a double. So if we say next double, we don't have to do any casting. And we expect that the next number to get typed in to be a double coming back. Probably not an integer, right? If somebody works 32.5 hours, they're going to get very mad if they don't get paid for that 0.5 hours. I think everybody's seen it before. Casting truncates, it doesn't round. So that 0.5 hours would just get discarded if we ask for an integer. All right, so there's that. So our others, we could do it in the calculation, Yeah, I'm gonna do it in the calculation and then I'm gonna clean it up. A general good rule of thumb for computers, ones and zeros, it's doing something or not doing something. It's doing something small or it's not doing something. So we're capable of writing big, long, complex, complicated lines. And there's a lot going on. But it's easier for us to debug and better for the machine if we do lots of simple lines instead. Okay. Machines do lots of simple things. So write your code that same way. A big, long, complicated line is, the machine's not gonna have trouble with it once it's debugged. The difficulty there is just for you debugging it. So small, simple lines are easier to debug. And typing's easy, don't be lazy with typing. I'm gonna write that complicated line first, because we can do it this way. So like double net pay is hours times our rate of pay, which if we can't remember where that index is, we can go back over here. Looks like rate of pay is the second thing. So we'll do that. Hours, actually, I'm going to clean it up. So first off, I'm just going to call pay. Hours times rate of pay, which is employee index 1. We talked about ternary operators. We talked about these. Oh, ternary operator job. Probably don't recognize the name. So this. We haven't seen that yet, have we? So that's a selection structure on one line. Probably should have seen that. Probably should have done that in. That's a very useful thing. So we're calculating overtime, or if we're calculating rate of pay, overtime is going to show up, right? So we need to see if we're bigger than 40 hours. And if you look here, you see there's a condition. We follow it up with a question mark, then true, colon, false. So a selection structure on one line. We can nest things in there. So we could nest another ternary operator in there, but that gets really, really messy really, really quick. And I'm going to delete this line in a moment. I already said it. I'm going to do the messy one and then we'll look at the nice cleaned up one. So we don't want to just multiply that, because before we multiply it, we need to know if hours is greater than 40. And a question mark. And that's what we do if it's not greater than 40. A colon, well, hours times employee times rate of pay times 1.5. I'll avoid jumping around this time because we haven't seen this. Then a colon, and we do the else part. Because if it's not greater than 40, then we just do hours times employee 1. Why isn't it like that? Oh, employee is a string, so we need to parse that. Double dot parse double. Then have all of that in parentheses. Maximize this. This one. Oh, not that one. Oh, there. Yeah, it was a couple times. Okay, it fit on the screen, so not that complicated a line yet, but I still need to parse the other one. But we can do all this in one line. Double, oh, not that. Double dot parse double. And one more set of parentheses, I There we go. That gets us our net pay. But that's a mess, right? The computer's not gonna have any trouble with it. It's us debugging it that's gonna have trouble with code like that. That's a ternary operator though, a selection structure in one line. It's an operator, so it goes just right in a single line for when we need to make selections. You all know how to clean that up, right? I was gonna clean it up, but I think y'all know if we split that up and did an if else, and then in that if else block, we did this, or maybe did this over a couple lines so that we have a couple things. Well, I'll go ahead and do that. Let's make sure that line works and then we'll clean it up. As out net pay. Give that a run. How many hours did Bob work? Bob worked 32 hours. And there's a number behind my Zoom profile. Yeah, that probably seems right. I could pull out the calculator, but it didn't throw an error. That's the big thing. So I think you're kind of got that. But that's a messy way to write code. We can do better than that. And that's for the code. That's human symbols. That's not what goes on in the machine anyway. Right? Everything gets passed through the arithmetic logic unit. So all we do is, there's no subtraction there. So all we're doing is running through a bunch of addition over and over and over again. So that's definitely not what's happening. It's a selection structure, that can't be much different than the if else spread out over several lines, so it's easy to debug. I'm putting them both in here. Messy way. This is only hard for the programmer to debug. Since I'm going to put this on GitHub here in a little while, clean way, same processing, but much easier to debug. Well, we have a selection structure, so we'll check if hours greater than 40. Oh, I always like to go ahead and block that out all the way. Then we'll do this. Actually, before I do that, I'm going to grab double rate of pay is this. Yeah, that's bothering me. It won't start. Copy that. And then we have that in a nice clean place. So if that's the case, oh, I'm going to comment on the earlier one, so I better re-declare this. That's going to be underlined until we get around to doing that. I'm going to leave it blank. So we declare it, but then we define it differently depending on that selection structure. Net pay is going to be assigned hours times more than 40 is rate of pay times 1.5 hours. Okay. And copy that and paste that down here and get rid of the 1.5. So both of those do the same thing. Okay. But one of those is going to be a whole lot easier for the human to debug. And we have this, there might be a slight advantage using ternary operators, but not significant enough to, not significant enough for the extra debugging difficulty we have with that big, long, messy line, right? But maybe you really like doing things like that. I tend to write a lot of those lines. I've done some really messy conditions where there's like nested ternary operators inside an if condition. So that ultimately it returns true or false based off a whole bunch of calculations. It looks like a mess. Awful looking code. This looks a whole lot better, right? Nice and clean, short lines. Everything has meaningful names, much easier to debug. So much better way to write your code. Because the computer doesn't have any trouble with either one. Writing the complicated line, you're only giving yourself trouble when you go to debug that or update it or something like that. We should get the same number. So 32 gives us 750.4. Is that still running? Oh, yeah, that's right. The stop button's right here. The big red button stops it. Here's what's still running. So if Bob worked 32 hours, we get 750.4. We get the same number from nice clean code spread out over several lines. Same result, but right either way, both of them work, obviously. I guess that's why I went ahead and include both of them. So that gives us Bob's net pay. Get rid of this echo. Oh, actually, we probably want the net pay. Because that's going to be part of what we want, right? We want the pay stub. Net pay minus deductions equals gross pay. So we need the deductions next. So I'll keep that line in there. And then the line B for the other one. And now I'm pretty sure I'm not going to need that loop that's commented out. So I'm going to go ahead and get that out of the way. If I haven't shown this, the home and end keys are really useful. If you do from well before most of y'all's day, well before you were born, back before we had a mouse on every computer, to highlight stuff we use the shift key in the navigation, like the arrows, page up, page down, home and end. A quick way to highlight a line is just click anywhere in it and then hit end, which is on a different spot on every keyboard, and hold shift and then home, and that'll select that line. And I always go to the end first, because if you hit home repeatedly, it just toggles back and forth between the end. So a really good way to select an entire line and get that out of the way really quick. Same thing up here where we started that. So I'll click anywhere, end, shift, home, backspace, and get that out of the way. Move those comments out. I'm putting it on GitHub right after class. I'll probably dismiss class before I upload it to GitHub, but it's a small thing, so I'm just going to use the web interface stuff, load to GitHub. Y'all probably don't need to watch me do that, as long as you remember what the repository address is, which I think is posted on our regular page. I think it's our net pay. And once we have net pay, we can find our deductions, because we did the simple, it's in our database just as one number. In a real situation, that's going to be a complicated calculation that takes a lot. Where we have all those IRS tables, exemptions, maybe some people's paychecks are getting garnished, all sorts of different things that are going to happen, which computers are great for those really nasty calculations. So custom payroll calculators are a common thing you will see, because those calculations are nasty. We don't want to sit down with a little TI-30 and try to do that for an entire company. Once we have net pay, our deductions, which we're talking about money, so again, it's going to be a double precision floating point number. Could use a float, but anymore, only game developers use floats. We're on 64-bit machines, so we have to use a 64-bit register every time. So if we use floats, without taking the effort to say double up things in the register, like it's already gonna be built into a game engine that's set to do things 140 times a second. If we don't take the time to do that, we're just gonna have 32 zeros in that 64-bit register. So we might as well use doubles. There's another good reason to do that. And this is deductions. Is net pay times I guess it needs to come from the array, doesn't it? I was thinking I should do like I did up here, but we already saw the clean code of the version. See, we already saw the clean version of the code, employee 2, which needs to be double dot parse double. And there's kind of a problem with that line. It's going to run fine. There's not a problem with it crashing. But does anybody see something that just seems a little off? It's on the screen right now, so it's something for humans, not for code, right? Somebody else looked at our code. We're not being consistent. Somebody else is trying to follow what we're doing. Up here, we went ahead and put that to a nice variable. And then out here, used it directly. Probably want to go ahead and do a refactor instead. Clean that up. That would run correctly. It's no problem, but we're not being consistent with our code. So if somebody else looked at that, it's going to be harder for them to follow it. And employee index number 2 is not very meaningful. If we get it somewhere meaningful, we can bypass the need for comments by making our variables self-documenting. I like calling that double tax bracket. I can't think of a name quick enough. Tax bracket to include all of our deductions. I'll just call it deductions percent. Because we already talked about how it's more than just the tax bracket. Deductions percent. Then our code's going to look a lot better, easier for us to debug, other people to make sense of, and things like that. There we go with that. Probably some output. So this one's seeming more like the way you normally write code, right? Everybody feeling that? I'm making little mistakes along the way, changing my mind. I try not to do this more than once a semester. I just like to make sure and show that the normal classroom examples are prepared ahead of time. So writing code, when I write code, even though I've been programming for a long time, it's still like what you're used to. Errors crop up, typos happen all over the place. We change our mind about the algorithm along the way. Just, I don't want to do this more than once a semester because that's wasting a lot of class time. But we already saw the syntax for this week, and then next week, do this before next week's topic. We haven't seen a full example, all we've looked at syntax. Probably wrote as many lines already up to the 50s, so probably about as many lines as we wrote out. Oh, and all that syntax example, right? So we need to start putting together our output. So we don't need the line break because we want it to look like the pay stub for each one of those employees in that data file. So first thing is going to be the name. Did I save that anywhere? No, we probably should have, shouldn't we? Let's follow that pattern of refactor our code. Everything else in the array we put to a meaningful name, so let's do that here. I'm going to hit Control X and oops, employee name, which is a string. Employee name equals that thing I just cut from that sentence. So that's refactoring. The code worked, not debugging it. We're just making our code, cleaning up our code, making it look nicer. refactoring as being as nice as you can to the person that will maintain your code. Imagine that you are never going to meet the person that maintains and updates your code. Be as nice as you can to it. Make it look really nice, clear, easy to follow, all of that stuff. And if you do that along the way, it's a lot easier. And now our code's a little more self-documented. We can look and see exactly what variable we're using. So when we need it again down here, we already have that stored. Employee name plus a tab plus the net pay plus another tab plus deductions and once this line comes together, I'm going to copy and paste this up to before that loop and take all those quote marks out of there so that it's labels. Those variable names are going to work perfect for labels on this as well, right? And then we'll have a nice looking little table. So we got our net pay and the deductions. So just one more calculation to get our gross pay. Double gross pay is net pay minus deductions. Payroll examples make great, payroll calculators make great examples in classrooms because we're Americans. We're all very well aware of how to do the payroll calculations. We double check our pay stub every time, right? Not many people in America actually trust the payroll company. Even though we know we're almost always certain they're doing their job correctly, it's just we're Americans. It's important for us. We're always going to double check their calculations. Or at least have a rough idea, get an estimate of it ahead of time. There's our gross pay. So add in another tab. So /T for the escape sequence. You can also use character number 9. I think, is that right? ASCII for horizontal tab is 9, yes. So ASCII 9, you can just ask for character 9. Make character data and assign the number 9 to it, and it will put a horizontal tab there as well. The escape sequences are used a little more commonly because they kind of fit with that half in English. Thinking about the ASCII code value is not the way humans think of that symbol. Oh, plus gross pay. Stop that previous run because it was still going. Run that and let's see what this looks like. 32. And now we got his name, his net pay, his deductions, and that looks roughly right. Pull that out and calculate it. Might want to do some formatting. But before we do formatting, those are some pretty good variable names. Those would copying and pasting that right as it is now would make a nice little header row up at the top. So end and then shift home is a quick way to highlight the whole line and copy that up to before the loop overall. This is going to be the same one for all of them. And fix the little things there. So employee name and then a tab. Then net pay and a tab. And I'm just using the arrow keys to highlight those the part I don't want. Get rid of that. Highlight this next part, bring that back. Maybe put a capital D in there, since it's a label. Then shift and the arrow key a couple times to get rid of that. And then our gross pay column. Oops. then the end of the string. But I guess it's a bunch of little, nice little, like, should give us some nice little labels up top. We don't need to go through our whole data set to test that, so I'll run that again. Uh-oh. The prompt seems to be in the wrong spot. So that's not gonna work for the labels. So I'm gonna copy that or cut that, and I'll give everybody their own labels. I'll do this instead. I'll print the labels in, and then as out a couple line feeds. Oh, which I did afterwards anyway. So I'll print the labels, the data, then a bunch of space. So it's kind of mimicking like printing out that pay stub, right? We print that out and then we come down to where our special paper is perforated. And then we print the next one with the same labels and the data and stuff. So it's gonna look like more like a pay stub. Is the plan there? Let's see if that works better. Stop that, run that. All right, so we get our prompt. How many hours did Bob work? For 32 hours. That work. And actually, if we're going to print this directly, we don't need a fancy prompt, do we? I was just suddenly realized it probably looked a little bit better if we just had the label for the label there, and the person that uses this software knows what goes there. So let's change that fancy prompt to the label for the output to save us a little time. Yeah. I'll keep the name there. So employee name. Employee name, tab, hours, colon, and we'll get the hours. And after they type that directly, just throw the date in there. We haven't seen a date yet, have we? Dates can be messy in Java. So I just kept the employee names tabbed over, put the word hours, and then that's where they'll enter stuff. So then afterwards, I want to do another tab. Notice no line feed. The line feed on this one, a tab, and then we'll put the date right here. Dates can be a little messy in Java. Date, Java. So public class date, okay, that sounds straightforward. So it allocates it. The time which it was after. Okay. Oh, that looks like it'll work. We have some other stuff after, before, well, and a lot of methods with it. Let's just go with the regular date. Yeah, that'll work. I was gonna do something different. We have different ones. So we have like Gregorian date, Julian date, different calendars, Unity talk, lots and lots of different ways we can do dates, but let's do a simple date. Then plus a new date object, which needs to be imported. So Control Shift I, not even gonna worry about what library it is, we already saw. But we might need to make some adjustments on that. So let's see what this looks like. Stop the previous run, run that. Oh, it jumped ahead, it didn't wait on us. Anybody want to tell me what I might be able to do to make it wait before printing the date? Yes. So cut it from there, and then these two lines, this line is waiting on something. So if we move it down here, it should wait to print. So stop the previous run and give that a run. There we go. So employee name, hours. Oh, whoops. Fix that bug immediately because we always want to fix one bug at a time. Things might be related, right? Employee name was a variable, not a string directly. We want the thing stored in that variable, not the variable name. There we go. So our employee name Bob, his hours were 32. When we hit enter, we get the date. That looks like a nice place to format it too, right? It just kind of worked out that it, yeah. If you stare at that for a moment, you'll see why it was formatted that way. It is starting to look like a pay stub would look like. It is employee name, net pay deductions, gross pay. Oh, whoops, another bug. The labels and the numbers should not be on the same line. The numbers should definitely be underneath the labels. And all that normal programming stuff. So we need a line on those. Actually, we could probably print a line on all of them. Oops. I can go ahead and put the line feed on all of them. Stop that. Let's give it another run. Bob worked 32 hours. Did I not print out the gross pay? Bob, name, net pay, deductions, name, net pay.
Yeah, the gross pay at the end is 6%.
Yeah, it looks like it just skipped. Oh, we have too much space here. So the employee name is too long. It passes more than one tab. So the tabs line things up, but actually might need two here. We still need to do that little bit of formatting. And all those things like we're used to. That's a little bit better. Bob's in the right column. Net pay is in the right column. Deductions, looks like deductions needs another tab afterwards. So \T. And give it another pass. You all know this process, right? Seen it a time or two. There we go. Now that looks like a pay stub. I wanted to make sure our output looked better than what you kind of what we would do in the prerequisites for this, right? We just print it out to the console and it's like, that's good enough. But really, that's not good enough, right? We have something specific. Our pay stub needs to be in a certain format for printing because there's usually very special paper that we print on. What's that term? Oh, yes, I'm getting ready to do that. We can do better than just rounding. Because that's money, right? So we want to actually format it. And we can do way better than rounding to 2 decimal places and manually typing a dollar sign. I'm coming over here to the documentation. But yes, great catch on that. Who put that in the chat room? I already forgot, I'm sorry. Yes, great catch on that, Dallas. We definitely want to do that. And in Java, or in the prerequisites to this class where you're using Python, that's our options. We can format it to 2 decimal places with or without, with rounding or truncated, and throw in a dollar sign. There is some format currency there, but it's a basic format currency. Currency Java. Currency is a data type in Java. Notice right here on the Java docs, there is a page titled currency. That's already a pre-built type of data. I'm going to use a different one. And not only that, it's the ISO standards. So it's not just going to throw in a dollar sign, it's going to throw in the standard dollar sign. Anything else that might go in there? What if we were in Japan? Dollar sign is meaningless there, right? Does the computer where this software is going to run know where we're at? Yes. We can block external software, but we're running locally. We don't block our location from the locally run software. We block the web applications, or we have the option, right? Block or allow. And a lot of people click block and they're like, oh, wait, I do want Google to know where, from what the local traffic report is, so it doesn't show me traffic in Boston. Because Google thinks that, right? We click that block without thinking, but on local ones, it has our geolocation. So it's going to know if we're in Japan or Switzerland or Ghana, or it's going to know where we're at in the world and format it correctly. There's another one, so that's there. Different things with currency. I actually want to use a different one here. So a more general one is we have a number format. Number format, Java, which has a currency method that does the same thing. It returns currency data. So when I've set up data type and number format, you can probably guess there's a lot of things in there that would be useful, right? We have number format type of data, and then it has a currency method. So I thought I would show this. I just wanted to talk about the data stuff first. Get currency or get currency instance. And you'll notice that they went and did a big bold thing, eye-catching thing for the difference between get currency and get currency instance. We're in the US, both of them are going to return dollars. If we're in Europe, get currency would still return dollars. So we want get currency instant because then it's going to check our location and run that. Or you can see the overloaded method right below it. We can tell it what location to check for. So yeah, we're in the US, but we want the Euros version. We're jumping on a plane tomorrow, so we need to know, or we're calculating payroll for somebody across, some company across the ocean. Or it's an international company, half of our employees are on the other side of the world. So the dollar sign in their pay stub's not going to be very helpful for them. So this one is a really nice one to use. But that one right there, I mean, look at those, look through that documentation. You see there's a lot of different ways to format numbers. And up at the top, they have examples. And a really convenient one, if you just like to do it yourself, is decimal format. Our format looks kind of like Yeah, as examples, yeah, we type in a pattern like this. Where we want the commas and everything and just put a hash. Actually, I guess we would say number sign there, put the number sign everywhere we want, the commas and the dots and the symbols and everything else we want to format that number there. I'm gonna use the get currency instance because it's built in and it's ready to work with our geolocation already, so we don't even have to worry about dollar signs or anything. So it's number format, we'll need to create an instance of that, some sort of formatter to work with, object, and then that object will have a get currency instance method. Did I click on the wrong thing? I lost my place here. We want get currency instance, this one. Yeah. Oh, that's Apple. So yeah, let's go type that. Or is there an example up at the top to see what that should look like? There we go. So we want the number format, get instance, and there we want to get instance, and then a dot format, the number we want to format. So we need all of that. So a number format, get instance, or maybe this might match what we were looking at a little bit better. We love the currency word in there. Number format type of data is going to be assigned number format get currency instance, and then later we'll do dot format on our currency. Then we can use that same one over and over and over again. This is for if you just have to do it once. But here we can store our formatter and then keep using that format over and over and over. So another quick pass at how to read the official user manuals, that sort of thing. Let's see. So employee name's a string. Well, let's set up our data. We can use the same one for all of our things, so that's going to need larger scope. So I'm going to come way up here to the top of things that are being used everywhere, and I'll create a number format. Number format, currency, seems like a good name for it. And that's going to be a number format, get currency instance. And our imports. And now instead of all that stuff like you were just saying, like you just pointed out, Alice, we have we'll have properly formatted currency for wherever we run this program at. Or we can, if we pass in something here, I guess that's gonna get complicated. If we pass in a location, some location data, it would print the logo for that. So net pay, that's money, so we can say currency format, and then the thing we want to format. And I'm just going to copy that because that's a lot of letters to type. And the computer is way less likely to make a typo than I am. Open that back up on a small screen up. Ran out of room. I will close that. And maybe we can put these down here. That's kind of out of the way. Deductions is money, and then gross pay is money, and need one more parenthesis. So all the lines went away. If you haven't noticed yet, when there's an error, let me get rid of that last parenthesis. The compiler notices the error, it underlines it, it gives us a little mark here, if I extend this. Oh, I apparently closed something I didn't need to. Projects, oh yeah, over here in the project panel, we can still see all of, it gives us that error message all the way up the tree. So we know when there's an error in there, we're not gonna miss lots and lots of redundancy on letting us know that there's an error. So that was just rinsing. It gets rid of that. The compiler caught it, but we haven't saved the file, so it's still up here on the tab and it's still over here in the projects view. When I hit save, then it cleared out of all those other views. So the compiler underlines it and then tells the other stuff about it. That sounds like you're asking about rounding. Actually split out the thing. If you ever need to round, go to the next place and add 0.5 and then floor the number. Just truncate it. So for money, you do plus 0.005, add that, and then floor it so that if you're below 0.5, it goes down. If you're above 0.5, it goes up. Is that what you were asking about there, Dallas? If we just cast it, like if we just try to turn that into an integer, multiply by 100, and turn that into an integer so that everything else just disappeared, it just truncates it. It just cuts it off. Oh, we'll stop the previous run. We don't need multiple instances running. So Bob worked 32 hours. There we go. Now it looks like money, and this will automatically round it correctly. We're dealing with money, so we will take that very seriously in their code. Gives us the auto rounding and all of those things. So quite a few new things, but some of that will hopefully be useful for you tonight. What else can we mark on our list? We have the list up here on the board. Let's see, so there's our output. So now we can keep going through the rest of the database. If I get those Zoom thumbnails out of the way again. Now we want salaries hours. So maybe Sally worked 43 hours. There's her pay stub. And Becky hours. Oh. Currency format only changes the way it looks. So that's what we would have here. If they both ended on a ½ cent, that ½ cent is going to get deducted. Write it out on paper. It's exactly like what would happen when you write it on paper. And this does not change the number. This only changes the way the number prints out. Did that answer your question, Alice? Sometimes it's really hard to answer questions. Here, let me write it on the board. I was getting ready to write stuff on the board if I understand you correctly. So like our net pay is 100.015, right? And our deductions are $10.005. Is that what you were asking about, Dallas? So this is actually more accurate. So I think you're thinking of rounding this first. So we get 0.2 and then subtracting that and we get 1.15 down there. So it rounds back up to a 2, which would be inaccurate. Right? Because 0.015 minus 0.005 should give us 0.01. So if we rounded first, we would get the wrong number. Because if we rounded that 0.15 up to 2, oh, actually, we'd get the same thing, wouldn't we? Then we round this up to 2, then we would round this one up to 1, and then we get 2 minus 1, so we get right back to 1. Some numbers might not work out so nicely, but the accuracy is still there. You never want to round money till the end. That makes a big difference. We write money in 2 places, but we actually count money in 3 places. You might have heard the word points. That's one word, that's a tenth of a penny. We actually count there. So all your bank money and stuff should round to 3 places, but only when printed out. Every computer the bank is running should have every single decimal place as much as it can, because otherwise things get off. Right? It's a big interconnected economic system. So if we take 1/10,000th away from somebody, it has to go somewhere. That means if somebody else got an extra 10,000. So we always want to keep our accuracy all the way through. You don't want to change it till the end. Oh, yes, I was also going to write other stuff on board. Did that answer your question? Yeah, basically, yeah. Don't bother with rounding unless you're printing it out, and then use things like formatting so that you don't change your number. You still have your number to work with. You just print it differently, make it look nice. And that's the only time we ever really want to round, because the computer has no trouble keeping track of all those decimal places. Let's see, so we finished that and that, got that, out for the results. So it looks like everything's checked off. I don't know, there's probably more time in here. I didn't write it down, maybe 20 minutes. That went on for a while, wasn't it? Because we actually did that twice to show that example. So 30 minutes there, and say 15 minutes on the output. All right, we got one of our numbers correct in that estimating time. But well, we missed one number altogether. So next time we can make a better estimate. Not going to do that every time in class for you. You can see that doesn't take long to just jot that stuff down, and it will be worth those couple of minutes in the long run. 30, 45, 105, 135, 140. So an hour and 40 minutes is 2/3 of an hour. So that's 4/3 of an hour. 4/3 times 75 should have made $100, but we only charged. We told them it would be $81.25. So then what happens? Do we take that $18.75 loss ourselves so the customer's happy and comes back to us again? Or do we go ahead and charge them $100? Like, yeah, it's going to be more than we told you. Okay. That's a phrase nobody wants to hear. I would say a happy customer is with more than the few dollars you can swindle them out of. Happy customer will continue being a customer, and you'll get way more than the few dollars you can swindle them out of these. For me, I would just go ahead and take the loss. Like, yeah, I told you 81.25, but let's stick with that. Took a little bit longer than planned. Not much of a loss, right? There's definitely a point where they're like, okay, some stuff went very wrong. The customer would have known about that well in advance, right? Like, things are getting extended. There's big issues happening. But then it comes into the business situation. What do we do with that discrepancy? And the more practice you get at this, the less discrepancy you'll have there. And then people will be happier and happier and happier because you're giving them what they asked for and accurately predicting the timeline so they can see where that went. Next time we know, spend more time putting the database together. Whatever this error was for, I should have written that there. Whatever we forgot to do there. More time there and little things like that. Just useful to get that practice. But there's a full example instead of just our syntax examples. Turns out nice, so I guess I haven't gone all the way through the database yet. Make sure we end nicely at the end. 38 hours, and David's hours were, I don't know, maybe he was feeling sick and took half a week off. And Mary had to make up for David taking off, so she worked like 49 hours. All right, got all the way to the end, no crashing. We read files, but we haven't wrote a file, so I'm just gonna copy this over to a file so we can see the whole thing. New file, paste. And there's our pay stubs. Right? We had the nice little perforated stuff. We could run it out the printer and then every one of them would be in the right place. It wouldn't be much to go ahead and put that in a check, right? We have the name, the pay to, date, and amount. So we have all the information for a check there. Oh, we don't have to do any more calculation, just more printing it out in the right spot to land on that paper, the specific paper the bank gives us. And it looks like we could do better, but it looks like starting to look like a pay stub should look like. That's a big thing. And the prerequisite, you are probably always just getting your number and printing it out. Because you move further and further along, remember that the proper format. You know, things, places where you've seen that type of output, make it look as nice as you can, make it look properly, because you're in 200 level class in at a two-year college, which means you're over halfway. You can already see the end in sight. You're up at the right number of levels to see that end in sight, so all that stuff's not far off in your future. Any questions about our example? I'm loading that up to GitHub. And a more thorough example than just our syntax pass and some of the thinking and what I do when I write code. That's not very good Java format. We'll probably do that better Java-wise. That's just the last pass of basic syntax. It's all in the main method. Very rarely do we do anything in the main method. Our main method is usually only 2 or 3 lines long at most. A lot of main methods are 1 line long where all we do is instantiate the first object so we can get away from that static stuff and work with normal object-oriented things. But if there's no questions, that was kind of the example I had in mind for tonight. I'm just going to use the website to upload it to GitHub, so y'all don't need to watch me do that. Couple seconds, if there's any questions. Okay, if you have any, let me know. As normal, I'm gonna be sitting here till the normal time, but you can ask me questions anytime. I don't have many plans for over the weekend. I'll see y'all on Tuesday and we will get into object oriented specifically then. Have a good one.